Now in kinetic theory of gases and radiations, last two articles are remains, that are the Stefan's law of radiation and Newton's law of cooling and greenhouse effect, that you know something about that. So this Stefan's law of radiation, the definition of this law is the amount of radiant energy emitted per unit time per unit area of perfectly black body is directly proportional to its fourth power of absolute temperature. So from the definition, we can represent it in symbols. That is the amount of radiant energy emitted, that is Q. That is the amount of energy radiated per unit time and unit area. So Q upon AT, that is the amount of radiant energy emitted per unit time per unit area. Now we are discussing about the perfectly black body. So it is directly proportional to the fourth power of the absolute temperature, that is T of power 4. Here Q upon AT, it is also equal to EB, that is the emissive power of a black body, that is directly proportional to the T of power 4, or we can write here EB, it is emissive power of black body perfectly black body. Now we can write this equation as EB, that is equal to sigma into T the power of 4. Fourth power of the absolute temperature, that is capital T, where this sigma, it is known as Stefan's constant. And it having the value in SI system, that is rho is equal to 5.67 into 10 to the power minus 8 joule per meter square second, fourth power of the Kelvin. Or we can also it convert in 5.67 into 10 to the power minus 8 watt per meter square fourth power of the Kelvin. So these are the values of the Stefan's law, which is a constant value. Now for ordinary body, we can use the formula, that is E, emissive power of a body, it is equal to small e into EB. That is the emissive power of a black body. Here we know that small e, it is coefficient of emission. Coefficient of emission. Here we say this is equation number 1 and it is equation number 2. Now substitute the value of equation 1 into here. In equation 1 there is given EB is equal to sigma T of power 4. So we can substitute this value in this equation. So substitute value of equation 1 in equation 2. So equation will be E is equal to small e sigma fourth power of the T. Then it is, we can say, equation number 3. Now when we perfectly black body is placed in a surroundings, then the temperature of a perfect black body, that becomes less or it lowers the value of capital T. So if perfectly black body is placed in surroundings lowers absolute temperature. Denoted by T0. So if we want to write in this form, then the radiant energy emitted to surrounding emitted by black body to surrounding, it will be equal to, we have already know in equation number 1, that is sigma T of power 4. Then emission of energy, radiant energy emitted radiant energy absorbed by black body from surrounding is equal to sigma T of power 0 T0 fourth power of the T0. So the net loss of the energy here in both the equation we can write the net loss of energy by black body of black body, it is equal to sigma, we will get common in bracket T power 4 minus fourth power of T0. So we say it is equation number 4, which represents the loss of energy by a perfectly black body that is interact with the surrounding. So it will be sigma T of power 4 minus T0 4. Then if for ordinary body, the net loss of energy of body, it is equal to small e sigma in bracket T of power 4 minus T0 of power 4. We say it is equation number 5. So in such a way, we will obtain the loss of the energy by of the perfectly black body, that is sigma of T of power 4 minus T0 power 4, and of any body, that is small e sigma T of power 4 minus T0 of power 4. So Stefan's law of radiation, it is nothing but the radiant energy emitted per unit time per unit area of a perfectly black body that is directly proportional to fourth power of the absolute temperature. Or we can also write Q upon AT, it is equal to EB also, that is the emissive power of a black body. It is also directly proportional to the T of power 4. So here EB is emissive power of black body. Now we can write this equation EB is equal to sigma of T power 4, whereas sigma is the proportionality constant and no rho is, it is also, sigma is called as Stefan's constant, which is having the value sigma is equal to 5.67 into 10 to the power minus 8 into different SI units. For ordinary body, the emissive power E is equal to small e into EB, where small e is the coefficient of emission. As EB we have in equation number 1, that is sigma of T power 4. We substitute here, then we will get the equation E is equal to small e sigma T of power 4. We say it is equation number 3. Now if we will take this perfectly black body in any surrounding, then its absolute temperature also lowers or less than its original value, temperature, that is capital T. So we can denote it by T0. So here the radiant energy emitted by black body, which are emitted, that is denoted by sigma of T power 4, and the radiant energy absorbed by the black body, it is equal to sigma of T power 4. So the net loss of energy of the black body, now we can minus in both the values and we take sigma as the common. So sigma in bracket T4 of minus T04, and for any ordinary body, the net loss of energy of body is small e sigma of t power 4 minus t0 of power 4. So this is all about the Stefan's law of radiation.